Hello you guys, in this video we're going to do an example with calloc. So why don't we get started? So the setup for calling calloc is the same as if we were to do it with malloc. We have a data type, more specifically a pointer to a data type, and then we'll need to cast to the data type that we want to point to, meaning a pointer to a double, because we're dynamically allocating double data, and I'll call calloc. Now, when I do this, well, what's the main reason? What's the big difference between calloc and malloc? Well, if you go play with malloc in your other program, you'll find that if you don't give it a default value, it's going to be junk, or data left from maybe another program, or an application that was running that you closed. One never knows. It's going to be unknown. It's just like declaring a variable, just some variable. You don't know what data is going to be there. It could be, if you're lucky, it's 0. If you're unlucky, it could be some weird junk. So the difference between calloc and malloc is that, well, malloc is memory allocation, calloc is contiguous memory allocation. And it also takes its input a little bit differently. So the first, rather than having one argument compared to malloc, calloc only has 2. First is the size of the data that you're going to have. Here I'm just going to create a single variable, and then the size that's going to be multiplied by the first argument. So I do size of double. Right, so this allocates one double variable. The equivalent for malloc would look like this. Notice how malloc only takes one argument, and it has to be just the memory that we want to allocate, while calloc has the memory that we want to allocate for the number of data, and then the size of that data that we want to allocate memory for. So let's go ahead and we'll just print the data that's here, just as is, and let us see the result. So it's pretty nice because the data here is, well, it's allocated, and its default value is 0. But you may argue, maybe we got lucky that the data here was just whatever, right? That it was already 0. So why don't we do another example with an integer? Let's say q. I'm going to cast it as a pointer to an integer. And let's say 20. Size of int. So here now I'm going to print all the values that's in q, which should all be 0. So let's see the result. It's all 0. You typically cannot get something like this if it was malloc. I actually just broke my own rule. I needed to free D, and I needed to free Q. So I have about some data that's not freed in my program. Oh man, these mistakes. But this is why you got to keep practicing programming. One thing that I need to mention too is that, while calloc essentially serves the same functionality as malloc, right? Again, the big difference is that calloc will zero out all your data that's there. One thing to ask is that when should you use malloc and when should you use calloc? Well, calloc, while it will zero everything out for you, that performance is a little bit low compared to malloc, because malloc just reserves the memory for you, right? Whatever's there, whatever's written to those addresses is there. However, calloc goes from the beginning and end of the memory that you're allocating and zeroes that out. Right, so we require n computations for the n data that we want to zero out. So when I call calloc here, we require one extra computation to set whatever memory that I allocated to 0. And here when I use calloc, I require 20 more operations to set the data, that's now q, to 0. Right? Here malloc just gets it. Whatever's there is there. Right, but here we get it and we zero it out. So there can be some performance issues. Calloc is a nice safety net because just in case you make a mistake and you access some data that's in there, it's zeroed out. That'll have its own consequences. But with malloc, you can get some weird junk, and that can, if you're doing computations with the data that you're allocating, it can totally whack out your whole program. Right, but if allocating memory is becoming an issue and the speed of it's becoming an issue, it's faster to use malloc rather than calloc. However, malloc can be considered a little bit unsafe just because it just grabs the data, you don't know what's there, and it could mess up your program. However, regardless if it's malloc or calloc, you always need to free your data. Don't make the mistake that I did earlier this program and make sure to free it. One last thing to note is that whether you're using malloc or calloc, the standard library is required, or right, stdlib.h is required to use malloc and calloc. Unlike using stdio, which you've been using for like printf and scanf and other functions like that, malloc and calloc, as well as free, they require stdlib.h. So this is a quick example of using calloc and how it's different from malloc. Again, not that big of a difference. Calloc just zeroes out the memory it allocates, while malloc just allocates the memory. You want to use malloc if speed is your need, and calloc if you want to be a little safer. All of them, whether calloc or malloc, require to be free at the end because both of these are dynamic memory allocation. And you can use Valgrind to check if everything is squared away. And actually, why don't I do that for this last example? Great, this is awesome. There are no leaks, and probably when I ran my program these two times, there were definitely leaks, and this time as well. It feels bad. And just so you know, this error here, I just needed to replace the comma with a semicolon. But that about wraps it up for calloc, and I will see you in the next video where we talk about reallocation.